Hello everyone, welcome back to another physics lesson. I'm Physics Michael, and today we're going to explore a key topic in kinematics, motion in two dimensions. We will begin with the concept of vector components, then look at the motion in a parabolic path, and finally learn how to use components to solve problems about objects thrown horizontally through the air. Let's dive in. To understand motion in two dimensions, we first need to understand vector components. Imagine an airplane flying at an angle of 37 degrees north of east. Its velocity actually has two effects happening at the same time. It's moving east and north simultaneously. So we break its velocity into two components, one pointing east and one pointing north. This is basically the reverse of adding two vectors together. We can say the total velocity equals the east component plus the north component. According to the triangle rule for vectors, and because the east and north directions are perpendicular, we can easily find each component. The eastward component is the velocity times cosine of 37 degrees, which gives us 80 meters per second. The northward component is the velocity times sine of 37 degrees, which gives us 60 meters per second. By doing this, we have resolved the velocity into two perpendicular directions. Similarly, any vector, whether its displacement, velocity, or acceleration, can be broken into two perpendicular components using an xy coordinate system. Let's use the letter r to represent a general vector. As shown in the diagram, vector r makes an angle theta with the x-axis. So the x component of the vector is r times cosine theta, and the y component is r times sine theta. This is a standard way to resolve vectors into horizontal and vertical directions. Let's look at an example with displacement. Imagine an object moves in a direction that's up and to the right, covering a distance of 100 meters. What are its components in the horizontal and vertical directions? Using the triangular method again, the displacement splits into two components, sx and sy. If the angle to the horizontal is 30 degrees, then Sx, the horizontal component, is 100 times cosine 30 degrees, which is about 86.6 meters. And Sy, the vertical component, is 100 times sine 30 degrees, which equals 50 meters. Now, let's do something interesting. When you throw a ball at an angle into the air, it follows a curved path called a parabola. If we analyze its velocity at different points along that path and use the concept of components we just learned, we can say that the ball is moving both horizontally and vertically at the same time. This is a key characteristic of a parabolic motion. It's two-dimensional motion happening in both horizontal and vertical directions simultaneously. So we can analyze curved motion using vector components in those two directions. Let's begin with a simple case, throwing a ball horizontally with an initial velocity u. If we ignore air resistance and use a multi-flash photo taken at equal time intervals, we will say the ball's path is a parabola. And if we focus on the horizontal directions, the ball moves equal distances in each time intervals. This shows it moves with a constant horizontal velocity because there is no horizontal force acting on it. However, in the vertical direction, though, we say the distance increases in each time interval, meaning the ball is accelerating downwards. That's because the only force acting is gravity, so it is free fall with g in the vertical. To look deeper, we'll break the motion into horizontal and vertical vectors. Starting with the initial velocity since it is thrown horizontally, the horizontal component is u and the vertical component is z. So we say ux equals u and uy equals z. Now let's look at the velocity after some time, t. Since there is no force horizontally, the horizontal velocity stays the same, so vx equals u. The displacement in the horizontal direction is sx equals u times t. In the vertical direction, because it starts from rest and accelerates under gravity, the vertical velocity becomes g times t, and the displacement in the vertical is 1/2 times g times t squared. The key point is the motions in both directions happen at the same time, so to find how long the object is in the air, we can use equations from either direction. And to find the total or resultant displacement or velocity, we combine the components using the triangular rule for vectors. So, by using vector components, we've taken a curved motion like a parabola and broke it into two straight-line motions, one horizontal and one vertical. This is a powerful method for solving problems involving objects moving through the air. Let's try an example. A stone is thrown horizontally with a velocity of 12 meters per second from the top of a vertical cliff. We want to calculate how long it takes to reach the ground, which is 40 meters below, and how far it lands from the base. Assume there is no air resistance. Let's consider the time t first. Theoretically, we can find it from either direction, but since we only know the velocity in horizontal, we cannot solve for t from this direction, so let's turn to the vertical. And consider the vertical motion. Since the stone is thrown horizontally, the vertical initial velocity is 0. The acceleration due to gravity is 9.81 meters per second squared, and the vertical height fallen is 40 meters. We will use the motion equations. Displacement equals initial velocity times time plus 1/2 times acceleration times time squared. That gives us a flight time of about 2.86 seconds. It is the time flying in both directions, but it's more common to be found in vertical. Step 2. Let's move to the horizontal motion. The horizontal velocity stays constant at 12 meters per second, and the time in the air is 2.86 seconds, same as in the vertical because they happen simultaneously. So, horizontal distance traveled is 12 times 2.86, which gives about 34.3 meters. That's how far the stone lands from the base of the cliff. Let's wrap things up with a quick summary. Vectors can be split into two perpendicular components, like horizontal and vertical. We use trigonometry to calculate these components. An object moving in a parabola is actually moving both horizontally and vertically at the same time. Horizontally, the motion is at constant velocity. Vertically, the object accelerates under gravity. So, using motion equations and vector components makes solving these problems much easier. That's it for today's lesson. Thanks for watching. I hope you now have a better understanding of vector components and how they help us analyze motion in two dimensions. I'm Felix Michael, and I will see you in the next video.